You know, you're using it every single second you're connected to a network, but you probably never ever think about it. Today, we're going to pull back the curtain on the invisible translator that makes everything work, from sending a quick file to a colleague to streaming a movie on your local network.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
All right, let's just jump right into the core puzzle. Why on earth does your computer need two completely different addresses just to talk to another device that might be literally feet away on the same Wi-Fi? I mean, it seems a little redundant, right? But as you're about to see, it is absolutely essential.
So the reason comes down to these two types of addresses. First up, you've got the IP address, the logical address. The best way to think of this is who you are on the network. It's like your house address. It can change if you move. Then you've got the MAC address, the physical address. This is what you are. It's like a permanent serial number that's literally burned into your device's hardware. It never, ever changes.
And this difference, this whole who versus what thing, well, it creates a really fascinating problem for your computer every single time it wants to send something. Let's call this problem the half-built packet.
So picture this. You hit send on a file to your friend. Your computer knows their IP address. That's the easy part. But here's the catch. The actual network hardware, the stuff that zaps the bits and bytes through the air or over the wire, it doesn't speak IP. It only understands those physical MAC addresses. So your data's all packaged up, ready to go, but it's missing that final crucial delivery address. It's just stuck.
So how do we get this packet unstuck? Well, thankfully, the engineers who designed all this came up with a solution that is just so simple and so clever. We're going to call it the digital shout.
And that solution is officially called the Address Resolution Protocol, or just ARP for short. Its entire job, its only reason for existing, is to be that translator, to build a bridge between the logical IP world and the physical MAC world.
To get that MAC address it so desperately needs, your computer does something pretty wild. It basically just broadcasts a message to every single device on your local network. It's shouting, "Hey everyone, who has this specific IP address? Please tell me your physical MAC address." And this whole process plays out like a really elegant three-step dance. First, you've got the broadcast. That's the big shout out to everyone. Second, the filter. Every other device on the network hears the shout, looks at the IP address, and just goes, "Nope, not me," and ignores it. And finally, the response. The one device that actually has that IP address replies directly saying, "Hey, that's me. Here's my MAC address."
Problem solved, right? Your computer now has the MAC address it needs, it can finish the packet and send the file. But this brings up a new question. Isn't shouting all the time just a little bit inefficient? And that brings us to the next brilliant step, the optimization.
I mean, think about it in human terms. If you were in a big office, would you stand up and yell someone's name across the entire floor every single time you wanted to ask them a question? Of course not. It's disruptive, it's slow, and it just creates a ton of noise for everyone else trying to work.
So computers do the smart thing. They take notes. It's a system called the ARP Table, but honestly, it's much easier to think of it as a personal cheat sheet. Once your computer goes through all that effort of shouting to find a MAC address, it just jots it down for later.
And that cheat sheet is really just a simple little table stored right there on your computer. It just maps the IP addresses it's recently talked to with their matching physical MAC addresses. It's basically a local address book of its network neighbors.
And here's why that's so important. The next time your computer needs to send a file to that same device, it doesn't shout. Nope. It just quickly glances at its internal list, finds the MAC address instantly, and sends the data. No broadcast, no waiting, no bothering anyone else. It's quiet, it's fast, and it's way more efficient.
Okay, so this cheat sheet is great. But here's the final twist. It can't be permanent. For the network to stay healthy and up to date, your computer actually has to be really good at forgetting. This brings us to the last piece of the puzzle, the maintenance, or as I like to call it, forgetting on purpose.
So, why would you ever want your computer to forget something useful? Well, because local networks are changing all the time. Your phone joins the Wi-Fi, your laptop disconnects, the printer gets turned off. If that ARP table was permanent, it would fill up with old, stale information really fast. Your computer might end up trying to send data to a ghost device that isn't even there anymore, which would just cause a bunch of errors.
So this is basically the short life of an entry on that cheat sheet. It gets created the first time you talk to a device. But if you don't talk to that same device again for just a few minutes, poof,
the entry expires and gets deleted automatically. This makes sure the cheat sheet stays fresh, clean, and accurate.
Okay, we've looked at all the pieces now. The problem, the digital shout, the cheat sheet, and the forgetting. So let's put it all together and walk through the complete journey from start to finish.
So, here it is, the full logic that happens every single time. Step 1, your computer always checks its cheat sheet first. Do I already know this MAC address? If the answer is no, then and only then does it move to Step 2, send out that big broadcast shout. Step 3, it gets a reply. Step 4, and this is key, it updates the cheat sheet for next time. And finally, Step 5, it can complete the data packet with the correct MAC address and send it on its way. It's just a beautiful, self-correcting, and super efficient system.
You know, the story of ARP is such a great example of these incredible, invisible translation services that are happening billions of times a second just to make our digital lives work. So the question I want to leave you with is this. What other invisible translators are out there, working tirelessly behind the scenes, turning all this complex computer logic into the simple, seamless experience we all rely on every single day?